Okay, so we've already talked about concentrations, right? Molarity. You guys remember molarity? What is molarity?
Mole solid versus over liters.
Okay, so moles over liters. So in this case, it says that if we have a 0.85 liter of a 5.00 molar solution of copper nitrate, and that's CuNO3 is diluted to a volume of 1.80 liters by the addition of water. What is the molarity of the diluted solution? So what am I going to do to solve this? What equation am I going to use? Or what am I going to do?
Use the C1, V1 equals C2, V2.
That is correct. Okay, so what is C1?
Concentration of
the 5.00.
Yeah.
What's C2?
That's what we're trying to find.
Oh, big question mark. V1?
Uh, 0.850.
C2?
1.80.
Okay, so we want to solve for C2. So we'll get what? Is that true?
Yes.
Okay, so then let's just plug and chug. So C1 V1 divided by V2. How many sig figs are we looking for?
3.
3.
Sig figs are important, right? We want to make sure we have it right. Oops.
Six.
And our units, molar. Piece of cake. So the beauty is that if we know the concentration, we can sit there and use this to make our dilution factors. So our concentration doesn't have to necessarily be in molarity. It could be any type of concentration. We can use percent mass. We can use percent volume. We can use percent mass volume. And so long as we're consistent about it, we should have no problems. Okay. Okay, so let me introduce you guys to some other forms of concentration. So as we already talked about percent mass, right? So percent mass is the mass of that particular component over the mass of the solution, right? We remember what a solution is. Anyone? Solution. I need a solution.
The solute plus the solvent?
The solute plus the solvent, okay? So the mass of the component would be our solute. right? So we want the mass of the solute divided by the mass of solution, and we multiply that by 100. Okay, so hold on. Now, if I remember correctly, and it could be, I could be wrong, but I think we've gone over this, right? You guys remember the bleach? Molarity, percent mass.
Yes, we did, Dr.
Yeah,
Henry.
we did the bleach.
Mhm.
Okay, so I'm not totally crazy, just a little crazy. So I'm just recapping what we've talked about, right? So at this point, you guys have already done mass percent, right? But let's give it a shot. Let's do something fun. So we did bleach earlier. So let's say we're gonna do I got it. So we're doing a solution of THC. So let's say I have 2.50 grams of THC.
Mm.
And the solution So what is the mass percent?
So would the 2.50 grams, would that go on the bottom since it's the solution?
So
The-
it's 2.5 THC.
Yeah.
So we're saying we have 2.5 grams of THC.
Mhm.
And I'm saying that it's in a altogether in a oil-based solution that weighs 20 grams.
Mhm.
So who's gonna go on bottom?
The 20 grams?
The 20 grams, yeah.
Oh, okay.
So we have 2.5 grams of THC. And our solution, which is that oil-based solution, that one weighs 20 grams. An easy way of thinking about it, the guy who has the biggest mass, that's probably your solution, right? If the smaller mass is going to be just that one component, but your solution is going to be the combination of both. So that should always be larger. Okay, so what do you guys get?
I got 12.5.
How many sig figs?
3.
3.
So piece of cake, right?
Yeah.
Good. Okay, so that's percent mass. We can also have percent volume. Okay, so we're making cocktails. We're gonna have vodka. Okay, so we have 35 mils of vodka. And we're gonna add, let's see, do 85 mils of water to it. Because Alexis and Raphael is coming over to the house and they like to drink too much. So I have to water down the vodka.
That's not fun.
Right? Just drinking
Okay.
water.
Why you gotta water it down?
So what do I need to do in this situation?
Put the 35 on top and the 85 on bottom.
So would it just be 85? Because we're adding 85
Would
mils of water.
Oh, to the 35. So you would,
Yeah,
so then I would add the two together.
okay.
Plus 35.
How many sig figs?
Two.
I think I heard 2, right?
Yeah, two.
Yeah.
So it's 85. Oh, I did something wrong.
Okay, piece of cake.
Yep.
Okay, so let's say that we have so Alexis and Raphael got tired of me being cheap, so they brought over their own vodka. That's 85% volume. But Morgan and Natalie came over and they're big luscious. And so they want to start getting cheap with their vodka as well too, right? So they decided, well, you know, I'm going to follow Dr. Henry's lead and try to save a little bit money. And so we're going to dilute it down to 5.005 liters. And then we're going to have it be 10% volume of vodka. How much of their 85% must they use?
Oy vey.
Okay. What am I going to do? I should say, what is Alexis and Raphael going to do?
Lost me.
Would you have to work backwards?
So don't we have like can't we use the C1, B1 equals C2, B2 formula?
That is correct. You can use that C1, B1 equals C2, B2. C1, B1 equals C2, B2. Gotta erase this down here.
Since our percentages are concentrations, correct?
Right.
Or they are volume?
That's right.
Yeah.
Since your percentages are concentration. Okay, so what is our C1?
85%.
And I should put a decimal point here. Okay, our C2?
10%.
Our V1?
5.00.
For sure.
Isn't that what we're trying to find?
Wait, hold on, but yeah, we're trying to find one, the first one. So that will be our V2 though.
Okay, so then our V2 is
5 liters, 5.00 liters.
You know, I just think about it. One day, somebody's going to come in my class and we're going to be talking about vodka. And they're like, this is supposed to be chemistry, right? Okay, so we want to solve for V1. What is my equation going to look like now?
Would be C2 times V2 over C1.
Okay, then it's just plug and chug, right?
Mhm.
You can make it a drinking game. And Natalie and Morgan could get sloshed, right?
One thing.
Oops, wrong one.
I know.
How many sig figs?
2.
Okay. Because I put that decimal there. Questions, concerns, cash, credit?
Mm.
Mm,
So just to get to the percentage, would you just multiply that to by 100?
But
So it'd be like 59%?
do we want the percentage?
No, because you just want liters.
Yeah, because this is our volume percent, right? So that's another way of saying concentration.
Oh,
Okay. So then we're gonna have 59 liters, 0.59 liters of that cocktail. Well, I erased the other part of the question. Sorry. Oops. And I'm on a roll right now. Yeah, I deleted it. It's gone. Yeah, so we were just looking for the volume. Okay. Questions, concerns, cash? So how you feeling about everything so far?
Good.
Pretty good.
Pretty good?
Yeah.
Did you say pretty horrible?
No.
Okay. Let's keep going then. Okay, so we can also have what we call mass volume percent. Mass volume percent is just that. It's mass divided by volume. And you multiply it by 100. Okay, so let's see. We're going to put salt. So if we have let's see, let me do the math here. Okay, so if we have 0.1, 0.0171 moles of sodium chloride, and we're making a saline solution, meaning a solution that has salt. Motion. Okay, that's the question. Show me those skills.
Dr. Henry?
Yep.
Is the mass over volume expressed as grams over liter? Does it matter, or the matter,
It's
or the
usually
units
it's
matter?
typically grams of milliliters. Okay, so what are we going to do?
Convert first the mole of NaCl by using the molar mass
Okay,
to grams.
so I have 0.0171 moles. And how do I convert that to molar mass?
Multiply it with molecular weight of sodium chloride.
Oh, the molecular
Which is-
weight.
Yeah.
So what is the molecular weight?
It's 23 plus 35.
Okay, so sodium is 23 plus 35. So what is that? 50.
58.
Okay, so that's going to give me,
The grams.
okay. Something like that.
Yeah. 1, 2.
Okay, so I got 1 gram of salt. So what am I going to do with that 1 gram of salt?
Divide it with 1000 ml of the solution.
How many sig figs should I have?
3.
3. Am I gonna multiply by anything, or am I just gonna divide it by?
That's it. The answer is 1.00 times 10 to the negative 3.
So you don't have to convert the milliliters to liters?
Nope, because I want it milliliters as my volume. So typically when we're talking about mass, the mass percent, we are gonna be using grams per milliliter.
Oh, okay.
Okay, so you sure you didn't forget anything?
Wouldn't you multiply by 100?
That's correct. That's that percent part. Piece of cake?
Mhm.
Okay. Ready for the next one? Everybody get it down? Yeah,
Yes.
no, maybe?
Yes.
Okay, so parts per billion, parts per million, okay? Parts per million and parts per billion are basically used when we have very, very, very low concentrations. And so we multiply them by, in the case of parts per million, by 1,000,000, right? So then that way that number doesn't seem as small. If we're doing parts per billion, we multiply by 10 to the 9th, which is a billion. So the number doesn't seem so small, right? So again, it's just that mass divided by the solution times 1,000,000 in the case of parts per million. In the case of parts per billion, it's the mass divided by the solution times 1,000,000,000. Piece of cake, easy to remember. Okay, so often this is used when you're working with poisons, or if you're trying to see, it's used occasionally in medicine. But if we're talking about pesticides and lead in water, lead in paint. Okay, so I want to test your skills on everything that you've learned today. So I'm going to pull up a question. Give me a second. Can you see my screen? Okay. Okay, can you guys see the question?
Yeah.
Mhm.
Okay, take a picture of it. I'm going to throw you in some rooms and you guys can hash it out. I want to hear some. I want to see whiteboards up.
Yeah.
A lot of discussions.
Yeah.
Okay, you guys ready?
Wait. I gotta take a picture. Okay.
Okay, let's see. So we have 17. Okay, so I'm going to say, I think it'll take you about 15 minutes, maybe less. 1, 2.
20.
We'll negotiate. 18.
What?
I'm just kidding.
There you go. Okay, so everybody's back. Everybody made it. Okay, so you guys want to start on that first one? Everybody got the first one?
Yeah.
Okay. So Nicole, do you guys want to show me what you guys did?
Sure. So, do you want me to write it?
Yeah, please.
Okay.
You see my handwriting.
Mine's worse. Yours is better. Okay. So we did our, well, what you did is you explained to us, since that it is parts per billion and parts per million, we had to find the similarity to the both. So we said that that was 10 over 3. So the given was 700 parts per billion. And then it was 1, and we need to know parts per million. So it's going to go on top. Three. And then we got 0.7 parts per million.
Okay.
And yes, the sink water is not safe because that's where this part comes in, and that's 5 parts per million. So it's over the dosage of mercury poison.
You got 0.7, right?
Oh, yeah.
So 0.7 is greater than 5?
No.
Okay. So we can go ahead and give it to our kids. They'll just be
Yeah,
smart.
I guess.
Okay. So let's see this second question. Did anybody complete the second one?
No, that one was giving us, we were having a hard time with that one.
Okay. So it says, if, let's say, it says, if the paint, let's see, if the paint gallon you're using has 7.6 milligrams of lead in it, assuming the density of the paint is 5.794 grams per milliliter. So what is the molarity of lead in your paint? What is the ppm of lead in your paint? What is the percent lead mass in your paint? Okay, so let's start off with the easy one. Molarity. What is the definition of molarity?
Mole solute per liter solution.
Yeah, moles over liters.
Moles over liters. Okay, so I want moles over liters. That's ultimately what I want to get at. Okay, and I know that I have, what am I given? What is my given?
7.6 milligrams of lead.
7.6 milligrams of lead. Okay, and if I want to change that to moles, what do I need to do?
From milligrams to grams and grams to moles.
Okay, so I want to go milligrams to grams. How do I do that?
You divide by 1,000.
Okay, 1,000 milligrams, and that's going to be 1 gram. Okay. Okay, so then how do I change this to moles?
Get the mass of lead.
Okay, so what is the mass?
207.2 grams.
So on the bottom or on top?
Bottom.
Okay, so then I got rid of milligrams, I got rid of grams. I have moles.
Mm-hmm.
That is a very small number. How many sig figs am I working with?
2.
4 sig figs. Oh, two sig big?
Four?
Oh, sorry. I'm looking at the last. Just kidding. Don't listen to me.
Okay. So am I done?
Oh,
No. So this gives me the moles of lead. And what is my solution?
1 gallon.
It's 1 gallon. Ah, 1 gallon. So if I 1 gallon, and I want liters, right? Because it's moles per liter.
Um,
How do I convert my gallon to liters?
1 liter is equivalent to 0.264 gallons.
Okay, I'm gonna write it the way I remember it. 1 gallon equals what? 3.785 liters. So, which is the same thing that you said. Only thing,
It's
I hate using decimals. I would prefer big numbers, bigger numbers. So, okay. So then, what am I gonna do?
divide the moles to the liter solution.
Divided by the liters of solution, and we have 3.785 liters.
(9.8 times 10 to the negative 6).
So you got 9.8 times 10 to the minus 6. Oops. Piece of cake?
not really. No.
Are you with me?
Yeah.
Yeah.
Okay. So then what is the next part of the question asked?
Parts per million.
Parts per million. Parts per million is what? What is the definition of parts per million? I'm getting old, getting gray. Help me out here.
Mass solute over mass of solution times 10 to the 6th power.
Mass of solute. So what is the mass of our solute?
It's 7.6 milligrams.
7.6 milligrams. So we should probably change that to grams. So what is that? 0.0076
Yeah.
grams. And I did that by dividing by 1,000 in my head. So I probably screwed up somewhere. Okay. And you're saying I'm dividing it by what? You said the
By,
mass of, I have to write that
mass-
down.
Mass
ppm,
of solution.
mass of solution. Do I have the mass of the solution?
We can calculate it.
You said we can or we can't?
We can. From
How
the,
can we?
we are given the volume of solution and the density of solution.
Okay, so we have the volume of solution, which was 3.785 milliliters. I mean, liters. And my density is in grams per milliliter. So I probably should change it to milliliters. How do I change it to milliliters?
Divide by 1,000.
Okay, so I have 1,000. Are you sure I'm dividing by 1,000?
No, you're multiplying.
Oh, multiply.
Okay. Thousand milliliters on top, 1 liter on the bottom. My liters are going to cancel out. Do you guys mind if I erase this part right here? Since I need more room. Since I write like a kindergartner. Okay, so then what do I do?
Multiply it by the density.
I multiply by the density because the density gives me grams per milliliter. So if I pay attention to my units, piece of cake. So what's on the bottom?
It's ml. 1 ml.
And then what's on top?
5.794 grams. It's 2.19 times 10 to the 4.
So you're saying 2, 1, 9, 3, 0. Point. How many sig figs should I have?
3.
3 sig figs?
4.
4.
4 sig figs. Okay. So I'm good right there, right? And I just want to put grams. Okay, so I have, and this is grams of solution or paint. That's the abbreviation for solution. Okay, so I have my lead and I have my solution. So if I remember you said I divide them by each other. Mass of solute over a mass of solution. Is that correct?
Yeah.
Times 10 to the 6. So if I plug that in, oops, that should be at the bottom. My brain's working on autopilot. Man, it's so quiet, I can hear the crickets. Times 10 to the 6. So then that equals
0.347.
how many sig figs should I have?
3.
Are you sure?
2.
4.
Should be
Okay.
say 3.
Okay, piece of cake. Okay, so we got the second part. What about the last part? The easiest part. What is the percent mass? in your paint, what am I gonna do?
It's just a mass solute or mass solution times 100.
So I just need this number here. Is that what you're
Yeah.
telling me?
100 multiplied by 100.
And then multiply it by 100. Okay. Piece of cake
It's a
or
lot.
lead?
How did you get the amount of liters there were?
Because it told me I had a gallon of paint.
Oh, okay.
I'm sneaky. So I'd be sure to read the problems because I am sneaky.
Okay.
Okay, questions? So what do you guys think is the hardest part of this? Is it the calculations,
Starting it.
starting it?
Yeah.
I'm starting it.
Okay, so what I recommend is you always try to figure out to start it. You're gonna almost all the time start off with what you're given. Now you need to recognize what you're given and what is kind of like reference or what is conversion. Density is going to be serving as a conversion in this question, right? Okay, so usually, not always, but usually conversions are going to give you some type of equivalencies, moles over liters, or some type of equivalency. Okay, grams over milliliters, right? Grams per milliliter. Okay, so those are usually your equivalencies. So your starting off points are usually those numbers that just have one type of unit with them, milligrams. Okay, so that's usually going to be my starting out point. And then the other thing is remembering definitions. ppms, percent solution, mass solute divided by mass over solution. And then percent mass or times a million. ppbs, mass of the solute divided by mass of solutions times a billion. Molarity, moles per liter. And remember, when you're talking about concentrations, you're usually talking about solutions. So that means everything as a whole. Because you remember the problem I threw in earlier, where you have to calculate your solutions, the volume of your solution. So you should expect a problem along these lines. Okay? Are you ready? Ready for the test? You want me to give it to you today?
No.
Okay. Good. So let's move on. Everybody get this down, or do you need a little more time? Kayla, what are we eating? What are you cooking up? What are we eating, Taylor?
Gum.
Gum? I
Double
thought it was something good. Darn it. See, I don't like chewing gum because I always want to swallow it.
Oh wow.
True?
How much gum? Can we calculate how much gum is toxic if you swallow it?
Yeah, we could calculate that. I'll have to set up a problem like that. Do a concentration problem dealing with that. Okay, so that's chapter 13. Now we get to go, chapter, I'm skipping chapters already.
13?
Chapter 3. That was chapter 3. You've learned concentration, so you're good. Now you're ready for everything. Okay, so now you kind of have to remind me. I know we've talked about this, right? So balancing equation relies on one principle, right? One primary principle, one law that I've been ingraining into you since we've met. Somebody's already telling me. Who is this?
Conservation of mass.
Oh, let's see. Hold on. People are getting kicked out. Sorry. Let me. Okay. We're good. Okay. So, what is that law?
Matter is neither created nor destroyed.
Matter is neither created or destroyed. And that law is called what?
The law of
Conservation.
yeah. I was gonna say conversation, but that's not how you say it.
That's all right, but at least you remembered it. That's right. The law, now you want me to say conversation. The law of conservation. Law of conservation of matter says that you can never create or destroy. Put it simply, what you put in, you must get out, right?
Yep.
Okay, so all we're going to be doing is changing who it's pairing up with. At the end of the day, what you're going to be putting into the equation, you should end up at the end of the equation. Okay, changing partners. So this is a combustion reaction. So if we have a reaction between methanol and oxygen, oxygen is kind of coming from the air and everything like that. Methanol is the gas that we're burning. We're going to produce carbon dioxide and water. Every combustion reaction with a hydrocarbon will produce carbon dioxide and water. Okay, so if you get a question about combustion reactions, you know you're going to be producing what?
Water.
And
CO2.
carbon dioxide. Okay. Okay, so the way that I would go about doing this is I would find out the elements that I have that I'm working with. What are the elements that I'm working with?
Propane.
Methane.
The elements.
Oh, sorry.
Carbon, hydrogen, oxygen.
Okay, so now we have our elements that we're working with. Now, on the reaction side of the equation, which side is the reaction side of the equation?
Left.
Okay. And the other side is called the what?
Product.
Okay. So on the reaction side of the equation, how many carbons do I have?
1.
Oh, my bad.
Okay. On the product side of the equation, how many carbons do I have?
1.
On the reaction side of the equation, how many hydrogens do I have?
4.
On the product side of the equations, how many hydrogens?
2.
On the reaction side of the equations, how many oxygens?
2,
On the product side of the equation, how many oxygens?
3.
Is it balanced? Am I done?
No.
No.
Okay, so what do I need to do to balance it?
Multiply it.
Multiply which side by what? So let's start off with this one here, right? C's are balanced, 1 and 1, right? They're looking good already.
Yeah.
What about these hydrogens? I have 4 over here. I have 2 over here.
Mhm.
So how can I get 4 over here?
You can multiply the H2O by 2.
So I'll put a 2 in front of the water.
Yeah.
So then that gives me how many hydrogens?
4.
That's what I want, right?
Yeah.
Yeah.
4, I'm good now. Okay, but if I count my oxygens, damn it, what did I do? So how many oxygens do I have on this side? Yeah.
Now you have 4.
So I have 4. Okay. Okay, so I got to fix my oxygens. So what do I
Yep.
need to do to fix my oxygens?
Oh wait, never mind. I'm tripping.
By the reaction side by 2.
So multiply by 2.
Yeah.
So is that right?
Yeah.
Okay, so we're good. It's a balanced equation, right?
Yep.
1 on this side, 1 on that side. 4 on this side, 4 on that side. 4 on this side, 4 on that side. I'm gold. Time to have a drink. Okay, piece of cake.
Yeah.
Okay, so let's make this a little more challenging. I know we're getting ready to go into lab, but we're going to do it anyway. Okay, so let's say we had combustion reaction again. But we're going to change this guy. We're going to do C6, H12, O6. Glucose. Okay, so in this case, oops, what am I going to do? How am I going to start?
Write down all of our elements.
Okay. Okay, Raphael. How many carbons do I have on my reactant side?
Carbons? 6.
Carbons.
6.
Okay, Balthazar. How many do I have on my product side? Might have lost him.
Oh yeah, he was saying he had connection problems.
Okay. Nadine,
Yes, sir.
how many do we have on our product side? Carbons.
6.
Product. This side, how many? You see 6?
Is it just 1?
1. That's right. Okay. Sean, how many hydrogens on my reactant side?
12.
Selena, on the product side?
For hydrogen?
Yep.
2.
Taylor, oxygens on my reactant side.
2.
Only 2? Are you sure?
Oh, 8.
Okay. And iPhone on my product side? Okay.
Five.
Angela.
For the product side
Yep.
of oxygen,
Yep.
3.
Okay, are we balanced?
No.
No.
Ah, okay. So what do I need to do to balance it?
Mm,
You need to add a couple sixes or a few.
A couple of sixes? Where am I adding sixes?
You're adding a few sixes actually.
Okay, where?
Sixes to 6 to the O2, the oxygen.
Okay,
Then you'll add 6 on the right side, both of them, on the CO2 and H2. H2O.
so you're telling me sugar's the devil?
Yeah, it's always been the devil.
Okay. So if we do the math, we have 6 carbons. How many
So-
hydrogens do we have here? We
12.
have 12 here. 12. How many oxygens do we have over here?
18.
And then on the other side?
18.
So we're balanced?
Yeah.
Piece of cake?
Yeah.
Okay. So we're gonna stop here. We'll pick it back up